Me. All right, so welcome to our second in-person meetup after the pandemic. I'm really happy to see everybody here, and also happy to be in person in this one. I would like to thank Sai for their kind for letting us use this room and their facilities. And thank you for coming in a rainy day. I really appreciate it. So in this meetup, we have Prodromos and Nikos. They're going to present a really cool tool they have built and they maintain, and how we can use it to generate code. I think that's it. So thank you, everybody.
Hello, everybody. So, just a second. So, welcome, everybody. Thanks for coming. So, let's quickly introduce ourselves. Hey, I am Nikos. I'm a Flutter engineer in Jakarta for about a year now, and I'm based in Athens. And today with me.
Hello, everyone. I'm Vanderlis. I'm a senior Flutter engineer at Jakarta, around 1 year too. Yeah, so.
Okay, so without further ado, let us jump right into today's topic, which is code generation, same but different. So today we will see how we can generate our data classes in a fast and fun way. And also we will see some of the capabilities of the Dart analysis server and how we can take its capabilities to the maximum. But first of all, what's a data class? So let's take, for example, other languages, like, for example, Kotlin or Python, where data classes have one main purpose, and that purpose is to hold data. Of course, the data classes come with a primary constructor and some default methods, like, for example, equals and hash checking, string representation, and, for example, in Kotlin, we have other functions like component and copy as well. Okay, so in Dart, a data class is essentially a regular Dart class that comes with an automatically provided constructor and implementations of equals operator, hash code, and copy with functions, all based on the fields that the user declares in the class. So this definition was taken from the Dart lang repository. I suggest you go there and see more stuff because this is really interesting. And also, I should notice here that usually in Dart and Flutter, we have something like, let's say, extended data classes, which contain also a string method for string representation, and also JSON support if we need it. So we have that as well. So that's a typical example of a data class in Dart. We have a user class with two fields, ID and email, a default constructor, a string representation method, a hash code getter, an equals operator, and a copy with method just to clone our objects. Nothing really fancy here, just simple Dart code. So data classes are not supported natively by Dart, but however, they remain the #1 requested feature in the Dart lang repository. As you can see, there is an open issue for about 5 years now to add data classes in Dart, and the community reacted pretty well, apart from 2 people, apparently. And we also should notice that the Dart and Flutter teams, and also obviously the community, have provided us with a lot of packages and plugins, so we can have data classes in Dart. Okay, so now let's see a few things about code generation in Dart and Flutter. So we can use code generation to generate pretty much everything. Yeah, we can have data classes, add JSON support, manage our assets, our navigation, state, translations, everything. And of course, the benefits are we save time and effort, obviously, by automating some processes that we would do normally by ourselves again and again, and that we should maintain this implementation also. Of course, we avoid some mistakes. It's always better to have some stuff done for you automatically instead of doing everything by yourself. And of course, we should remember that copy-paste can be really tricky and risky. So let's protect ourselves. Of course, also we have code and asset safety in our applications. And finally, our code requires less testing because, let's say, for example, if we add JSON support in a data class, we do not need to test our JSON and from JSON methods because this is like testing the package itself. So again, we save time and effort. Okay, so code generation in Flutter is done most usually by using pub packages. I bet most of you must have seen this command. So let's see a few things about build runner. So build runner is a build system for Dart code generation and modular compilation. It provides a concrete way of generating files using Dart code. The files are always generated directly on the disk. And finally, the rebuilds are incremental. What this practically means is that the build runner is the engine that generates our code based on instructions from the packages. So pub packages need mainly two things to generate code for us. First of all, they need access to our code and then access to the build runner. So let's see how this goes. They usually depend on a package called SourceGen, whose main purpose is to expose a developer-friendly API on top of lower-level packages like Analyzer or Build. The Analyzer package provides a library that performs static analysis of Dart code, and it is useful for tool integration and embedding. And finally, we have the Build package, which is used for authoring build runner compatible code generators, and it defines the basic pieces of how a build happens and how they interact. So here you can see some of the most known packages that we usually use in Dart and Flutter. So now that we have seen some things about data classes and code generation, let's see how we usually create our data classes in Dart and Flutter. Okay, so first of all, we can always create our data classes manually. They're simple methods after all, so in most cases it shouldn't be that hard. It is mostly used by new starters, simple projects, or to avoid extra dependencies. Then we have the build runner packages, as we explained before. The most common ways of generating data classes is a combination of the copy with extension with the equatable packages, as well as the JSON serializable package if we need JSON support in our project or in our data classes. And on the other hand, we have freeze and JSON serializable, again, if we need JSON support in our models. Please note here that equatable is not a code generator, so manual code is still required. Okay, so now let's see some issues with build runner. First of all, it might be hard to use, especially for new starters or in projects with multiple packages. You have to learn and remember new commands and run these commands in every project, in every package you have in your application. Also, usually the generated code is quite complex. It's hard to navigate through the generated code and understand it, or even worse, debug it sometimes. Here you can see a typical example of an exception in Firebase Crashlytics. This is a pretty common error we can get. The backend sent an unexpected response in our application. So yeah, it's worth noticing here that the generated file, the Facebook profile.g file, is at least 250 lines long, while the actual data class is less than 50 lines. So yeah, you can see here that a lot of code is generated for our data classes. Also, build runner adds a lot of dependencies in our projects. A common example is when we use freeze and JSON serializable, which adds 5 dependencies in our project. So this is a typical PubSpec YAML. You can see we have 2 dependencies for our annotations, and 3 dev dependencies for our packages that generate code for us. Then the code generation becomes slower as the project grows. It consumes more resources as it recreates generated files when Dart files change. So here, for example, you can see that for about 200 output files, it took more than 40 seconds to finish, and that was on a pretty decent machine. Also, it creates at least one generated file for each Dart file. That means that we have a lot of generated files in our project. And a common example is freeze and JSON serializable that create 2 files. This happens because in our main data class, we need to specify 2 path files. And this is how the output would look like. As you can see, we have the main data class and 2 generated files. Also, we have the IDE plugins. We have IDE plugins for VS Code, IntelliJ IDEA, and Android Studio, which is pretty much the same thing. These plugins are not dependent and not related to our project, but they're installed on top of our IDE. This, of course, introduces some challenges and risks. First of all, it requires consistency between different IDEs. It requires extra installations and updates. And of course, plugin creators need to maintain compatibility for multiple IDEs. This means that, for example, in a team that we have a lot of people in it, it would be quite risky sometimes or tricky because we need to use the same plugins to have the same generated code. And also we have static metaprogramming. Metaprogramming refers to code that operates on other code as if it were data. It can take code in as parameters, reflect over it, inspect it, create it, modify it, and return it. Static metaprogramming means doing that work at compile time and typically modifying or adding to the program based on that work. Metaprogramming is not available yet in Dart, it's still under development. So we'll not see more things about it, at least now. So I would suggest you to head over the Dartlang repo and read more things, more information about static metaprogramming. And finally, we have the data class plugin. So please help me welcome Pantelis, who will introduce data class.
So, thank you, Nikos, and hello to everyone again. So, the data class plugin. What's the data class plugin, right? It's a tool that uses the Dart analysis server to generate code on the fly within your IDE. How does it work, right? So, it uses 2 packages, mainly. One is the analyzer to access your code, parse it, understand the structure of it, and then the analyzer plugin to integrate with the Dart analysis server to provide actions based on your code, right? So how we can install that? It's a simple dependency on the path spec. So you add it like a data class dependency, so like a normal dependency. Then you need to update and register this plugin under the analysis options file. So this goes to the analyzer plugins section. And then the last step is to restart the analysis server, which can be done directly through your IDE. You need to run an action for that. So what are the benefits of the data class plugin? Well, as we saw, it's a single dependency, right? So we don't need to add many things now. It supports everything that you need. It's easy to set up and customize. As we see, we only need to update the analysis option, and then we need to restart the analysis server. And also, it's customizable that you can provide all the options that you want to generate the code based on the folders based on folders or files that match your needs, right? So you can do this for all the options of the generated code that you can generate. It integrates with the Dart analysis server, so that means it's not an IDE plugin, but it's a Dart analysis server plugin. So it's IDE agnostic, so it can run on VS Code, Android Studio, or IntelliJ, or even some terminal editors that can communicate with the analysis server, like NeoGAME. It runs per file, so when you want to generate the code, you have to do it on the file that you are working on. So it doesn't consume any more resources than necessary, like a build runner. It creates no output files, so all your code is generated directly on the original file. And also it produces simple code, which is easy to read and understand, which is very important when you are in the development process. So you can debug why it's not generating what you're expecting. And also, as we saw in the crash reports, it also can speed up the time to find the error. So some of the features of the data class plugin. Well, it supports data classes, the main purpose. So you can generate like the constructors, copy with, hash, and equals, and also the toString, from and to JSON conversions. And also it supports generic types and superclasses. It also supports union classes. A union class is, you can think of it like a sealed class that has only specific implementers, right? So one example would be when you want to receive some synchronous result, and this synchronous result could be like on one of two states, either a data result or an error result, right? So what union classes do for you is that they provide you a type-safe way to check against these results, and you don't have to use the is keyword of Dart. And maybe in the future, like you update this class and add a third state, right? So now you have to go through your code and read that code and see where do you use it, and maybe you need to add this third checking with a new class. But this way, with union classes, it will provide you a compile time error that, oh, you should use this and check this new constructor, the new union types that you have added. About JSON serialization, we have, for everyone that has used JSON serializable, it supports like customizing the name and customizing the naming convention, and also add custom from and to functions too. And for enums, it provides you with a simple way to create like constructors or from to JSON conversion again. So, are there any questions before moving to the demo? I guess not.
Now is the time. Now is the time. Data classes.
Okay, let's jump to the demo. So, first, let's see what we are building. Like, it's a simple app that you can search for music using free API. It's not what we will focus on, but yeah, it has like you can search for, you can get like a spinner that is loading the data, and you can get this result back. So this all is in a state, right? So yeah, I will write my common one. So now it pulls the data through an ASCII file. It doesn't go through directly through the API. We will see how that works later. So let's see how we can start creating our data classes. So we have this like this. We have our project here. So the first thing that we do is install our dependency, right? So how we can do that? We need to add it. Doesn't work here, I guess. Okay, doesn't matter. So let's add it manually. Data class plugin.
Μπορείς να κάνεις λίγο zoom στο webcam σου.
I think that's better.
Για να ρωτήσω αν είναι ok. Εντάξει.
Yeah, so we have our dependency installed, and now we need to update the analysis option. So every newly created project should have this, or every project should have this, so we can have some linking on our project. So what we need to do is introduce the analyzer plugin section, and then we need to register this plugin, right? So this is the plugin name. So the data class plugin is the same as the dependency name. And the last step is to restart your analysis server. This can happen directly through your IDE. For VS Code, you can open the command palette and type like restart analysis server, this command, run this. And you know when it's ready when you see this analyzing thing stop analyzing, right? So, or your project is analyzed again, and we are ready to go. So let's go through the structure of the project. So we have an API that we can use to fetch some tracks. We have the models of the app, simple data classes. We have a provider, some providers. We are using Riverpod for state management and dependency injection. We have a repo, a simple repo for the songs, and we have a page, like a home page, nothing crazy. So let's start working on that. The first step is that we need to add models for our two classes here, right? So I have already created the data class for the other classes, so we go through some examples. So, for example, the artist has all the methods that we already need generated for us. So what we need to do, the first step is to annotate our class with the data class annotation. We can click on that, we get the import automatically, and now we are ready to generate our data class. What we have to do is to call to get the actions from the IDE. So this is something common that we see with Flutter when we are building widgets and we want like to swap a widget with its parent or add a builder or a stream builder. Like you press like Control dot and you get a list of suggestions with whatever you can do. So this works similar. So this is based on the OS and also the IDE that you are working on. So you will recognize this UI, I think, whoever uses VS Code. So we get these more actions, generate data class, right? So by doing this, we will have our data class generated. So we can see that it has different methods. It also created a constructor for us, created the toString method, created the hash code and the equals, and also a copy with method. So that seems pretty nice, but it's not entirely what we want. We want for the models not to have these copy with, and also we want the from JSON. So what we can do is go here and see a list of options that we have. Like we can provide like Boolean value for all these options, and the generator will respect these options and generate the code that we want. But for this case, we won't use the annotation, but we will use this config file, the data class plugin options. So this is something that you can do and provide a global configuration for your project, right? So in this example, let's go with the copy with. We can provide for which paths or like we can use globes to match which files and folders we don't want to use for our generated code. So I have already created the setup. So for copy with, we have disabled the libs/models / pretty much everything under the models folder, and also the libs APIs everything under the models and every file again. So this is something that you can do on your project, and so you can have like a global setup that you don't need to go through every class and annotate, like add the values to the annotation and select which methods you can use, right? And also you have, again, you can have this in a global scope. So for example, the default global scope is default true. So if you don't have this, it will work like this for every project, right? So this is respected. So for example, if it matches a file under the lib models, this will take precedence over the default value. So this is how it works under the hood. And also you can provide like, again, this on a JSON, like for JSONs in a global scope. Again, for now we have this JSON key name conversion to camel case. So everything that will generate code for to or from JSON will be, it will use camel case for the key. So now if we go back and rerun the generate data class, we will see that nothing changed pretty much. Like we have again the toString, hash code, and equals, but now the copy with is replaced with the from JSON method, right? So we have what we want, and we didn't need to restart anything. It works every time that you update the file. So let me take this on the top, so we have a bit more a bit clear. So you see here that the from JSON generates everything that we need. It goes over the items, like the name of the key is the same name as the variable name. It goes through all the items and uses the artist from JSON constructor to generate the object that we want. Now that we have this, we can generate our track model too, like the same thing. Go to the data class, so we do the class, we add the annotation, data class, generate the code, and it has everything that we need, right? So again, toString, hash code, equals, and the from JSON constructor. Let me again move this on the top. So as you can see, this is like a pretty fast way to generate your data class without needing anything else. Like you, people that have used Build Runner and the project scales, you can see that this starts to become slower and slower as the project grows. So this will have the same, pretty much the same generation time. So if we go through this from JSON, we can see that pretty much generate a simple code. We can use the track artist from JSON and everything is cool until this point where we see this JSON converter registrant, right, and use the duration. So this is something that the plugin provides you with a way to register in a global scope all the classes that you cannot control and add from and to JSON, right? So it's like a converter system that you can register converters, and the code generation will use this when it cannot find an appropriate method like from JSON or from map. So that seems pretty good, but we don't really want to use this. If we open our assets file and see, sorry, and yeah, that doesn't go well. So we are using these tracks for now, like the app uses only this tracks model. And if we see this model, and compare it to the generated from JSON, we will see that two of the variables are not the same with the JSON key, right? So we have this album that uses the album of track, and also the duration is not an object. Like it's not just a value, it's an object, right? That has duration and total milliseconds. So we want to do some customizing on that. So how we can do that? Let's start from the album variable. We can annotate this with a JSON key. For everyone that has used JSON serializably, this key is pretty much the same, but only has whatever is necessary. You can provide the name convention, and some methods to map to. So the first step that we need to do is we want this key to be the same as our API response. So we need to provide the same name. So if we do album of track, hit generate data class, we can see that now the generated code down here respects this value, right? So the same key is used, which is pretty cool, I believe. So now let's see something more complicated. We want this duration total milliseconds to be converted to a duration, to do a duration object. How we can achieve that is we can provide a custom from method to inform the code generator that you should use this method when you transform from a JSON. So how we can do that? We can use again the JSON key and add the from JSON method. So if we add this name, it should work. So we can create a static method for that. So methods that go to annotations can be only static or a top level function, right? So what we want to do is create this function at the JSON, and then we want to return a duration object. Before moving on, as we can see that this method says it's dynamic, right? So we can pretty much provide that in here without having a compile time error. So how we can fix that is that the JSON key takes also the name, like the type of the parameter. So it can provide you with some type safety, or you are trying to use this dynamic, but I'm expecting a duration, right? So it's a small hint for us to use the correct method. So what we want to do is use the milliseconds parameter and just convert that from JSON duration total milliseconds and use this as int. So now if we generate the code again, you can see that now it uses for the duration this track duration from JSON. Actually, that's a wrong name. Yeah. So we're done with our data class. That was pretty fast, I believe. So let's move on to some different things that we can do. If we go to the models for the API, we have two models. One is for, let me close this. One is for the request that we will do, and one is for the response. So let's go through the request first. So request is a simple model that has some parameters like query, the type, offset, limit, and number of top results, right? And we have created our to.json for this, generated by the data class. But also we have created a constructor which we can modify. Like it creates for us a simple constructor, as we saw, for example, with the track. So we had this constructor, right, generated from the code generator. But for the search request, we want to provide some default values. This can be done with the code generator. It will respect your changes to the constructor definition, but only for this method. All the other methods cannot be altered. So if I generate the data class again, nothing changes, right? Because it respects whatever I have placed there. And also we can see that this search type is an enum, and we have created like the toString and to.json from, again, the code generation. This can work without an annotation. We get some assistance from within the IDE. So let's see this example of the search response. So this is a bit more complicated on what we try to achieve. So if you go through the data, you will see that it pretty much is the same. It has the same form, right? You have an object that has a total count and an items array. So we want to not duplicate this same object over and over again. So how we can do that is we can use generic types. So that needs a bit thinking of how you structure the data. So we want this data key that has the data object. We want this to be wrapped with a generic type. So we create like a simple class that holds only this data, right? Nothing more. So if we generate the code now, and see here, we'll see the from JSON method has used again this JSON converter registrant to find a type of T and use that from JSON. So how does that work? We will see in a bit. Let's move on for now. Let's see a bit later how we can what we want to do is like how we can have this track be used as a T type, right? Like a generic type. So this information is not provided for you at compile time. It's only provided at runtime. It only knows the type of T only at runtime. So that's why we need to use this JSON converter register. So next is the search type result. So this wraps this part of the API, is the total count and the items. So again, if we go here and generate our data class, we will see that we have this from JSON, uses again the total count and goes through all the items and uses this data wrapper from JSON. Nothing special. And now, if we again generate the code here, we will see that the search type result uses the track model, and also it respects the nullability on that field, right? First it checks for us if the model, like if the data from the JSON is null, then you don't need to convert it from JSON to an actual data. You can use the null value. So that would be easy for us. Let's say that we have something else. We can copy, paste that, add like a playlist, then add the playlist model here and rerun the code generation and do it again. So if we do that, it probably won't work as we expect. It's partially working, but it's not entirely what we want. So because this playlist doesn't exist yet, you have to create this model to work. Can reuse this logic for the code without needing to create different models. So let's see how this JSON converter registrant works. So, well, this is a symbol, if you can think like a map, that it finds a type and provides you with a converter, right? So this converter has the from JSON and to JSON methods. This can be used for packages that you cannot control, like you have a package that you have a model from a different package that doesn't provide from and to JSON, which can be common. And also you can do it on native data classes, native classes like the URI, daytime, and duration. So the plugin provides you a default implementation for that, but you can also override it if you want to. So how we can use this JSON converter now to register our converter for a track. What we need to do, I have already filed here. First, we need to, this works like that for normal project. You need like a function, let's say register JSON types, that will call the JSON registrant to register all your converters, right? So if we use JSON converter register, and use the register method, we can do something like track JSON converter and register this. So this doesn't actually exist. So we need to see how we can create this struct JSON converter. So we need to implement a class that is called like JSON converter. It's a normal name. So in this JSON converter and implements JSON converter. So this JSON converter takes two parameters as a type, is the in type and the out type. So the in type is from what you want to convert, so the actual data class model, to the JSON representation. So we want to convert the truck into a map that has a key string and a value dynamic, right? So if we go to the JSON converter and create the two override methods, we will see that now we have this from and to JSON that it can be used from the JSON converter and the find method, right? So this is the find returns you a JSON converter object based on the types that you provide. Now, as you remember, we have already created our from JSON for our model, right? So what we can do is use this track from JSON, provide the value, and we are done with it. And also about the to JSON, because we don't necessarily use it right now, sorry, we can just leave this throw an unimplemented error, so it will crash if we for some reason we use that. And the last step is to go to your main function and call these register JSON types that we have created, right? So this is the function that we have created that calls the register for all our custom converters. So you use this once in your project and you don't need to do anything else. So we save that and this is ready. Oh, are there any questions until this point?
I have like 2 questions and you got me covered. So
Okay, that's good. Yeah. So now that we have our models ready and the models for the response, let's see, we can use a union type, right? So we have this repo result that will return us data for a union. As I mentioned earlier, we have like a state of data and a state of error, right? How this works is, first you need to annotate your class with a union annotation for that to work. Union. And also, again, here you have different options like a data class from and to JSON. And for this example, we want to have the from and to JSON set as false. And now we are ready to go. So how this works, has anyone used freeze before?
Yeah.
Okay, that's good. So because Dart doesn't provide you with a native way of constructed union types, we have to do it in a bit hacky way, if we can say that. So we have factory constructors that they will redirect how they are constructed into a different class, right? You can redirect a constructor from a class to another one. So this equal sign and the name of the other class will be generated for us when we run the action. So if we generate the union, now it generates a lot of code for us. Let me save that. Yeah. So now we have this repo result. We have the repo result data and the repo result error. Go to the repo result data. We can see it has everything that we have declared in this constructor, right? So we have a constructor of type T and it accepts a data object. So if we go here, we will see that again, we have this final T data, we have the copy width, we have the hash code equals to string everything. And also it extends this class. So we can use it to to create new types for these new instances. And also the repo result error, again, it has the same structure, but it uses its own fields, right? So these union types, while the name is a bit weird, union types come from like C and C++. You had like union types, and you had like shared memory space for. So if you had like a double and an int, right? So they take like 4 bytes. It wouldn't allocate I can't do the math. It wouldn't allocate the memory for 2 variables. It will allocate only for ones. That's why they are called union. But here they have a different usage. So that was a bit unnecessary, but good. So the main part that we need to focus is this when and maybe when function. So a when method, you can call this on the repo result and get a type safe callback that will run based on the type of the variable that you have created. So in the main context, we will only use this repo result, right? So variables will have this type. But when you create the instance of this repo result, you will create by using one of these factory constructors, the data or the error. So when you want to check if the repo result is one of the either, like the data or the error, you want to use this method to provide you with a way that it can let you know in the future that, oh, you have updated this class now. It has more than 2. It has like error 2, or this is deprecated and now this is a new way of constructing things. So and when you generate the code again for this, it will provide you here with a third argument. So you have the compilation error if you don't handle this, right? And also the maybe when, it's pretty much the same with when, but you don't have to provide a callback for every constructor, but it forces you to have a callback that will handle the default case if you don't provide anything. So let's see how we can use that. First, a simple example would be like the search for tracks on our repo. What this does is it just returns a repo result that has a list of tracks. So in case that everything goes well, we create a repo result with a data constructor and provide all the data that we want. But if something goes wrong, we need to use the repo result error constructor and provide the data for an error. And how we can consume that now? If we go to the homepage state notifier and see where do we use this, we'll see this songs repo calls this method, right? And we have this result that has a type of repo results list of tracks. So what we want to do is we want to update the state of the homepage whenever we get a result from a repo call. So we can do a mapping of the result, like using the when, and what we want to return is a homepage state. And what this will do is when it's data, it will call this callback. And what we're doing here is just use the copy with method that is generated again for us. If we go to this homepage state, there's something generated again through the data class plugin. So we have an easy way to update a model with new parameters, with new values. And also when this is an error, we want to update again the state, but with something that indicates to the app that we have failed to load any results, like a network connection. Like you can provide pretty much everything. You have like a repo result and have the reason why it failed. Like, oh, you can update that with. You can make the error more specific. It was network. Like have a factor constructor that is network, or you are unauthorized, or whatever we want, right? This depends on how you structure the code. And yeah, so if we go over to our state, again, everything is generated with our data class plugin. We have everything here, and also the constructor again is updated with what we need, and this will be respected. So if, for example, if I add a new field, let's say string, and add this, the changes remain as they were for the constructor, and we have this new field added. So I think pretty much that's all. So the latest step is to run the app and see if it works. So I will remove this and use the actual implementation and hope that builds quite fast. Until it builds. Any questions?
We have some questions from people online. And Nick is asking two things. First of all, you used for JSON representation, you used map dynamic. Why not map string dynamic? One question.
Yeah, so the main reason for that is because you are not really aware if you will get a map string dynamic, right? Because some APIs like Cloud Functions, they return the data, for example, for nested object, like nullable object. Like for key, you have a nullable object, and also for value, you have a nullable object. That means that string is not always the case. So if it's not the case, it will crash. So that's why it uses dynamic and expects it to be a string, to have a string representation for that.
Okay. And the next question is, Flutter releases often the new stable version. How often do you upgrade to the latest? Again, from Nick asked.
Yeah, because the plugin is pretty much new, so it's up to date with the latest. So, and yeah, it will try to keep up with it. It shouldn't introduce any changes when the Flutter upgrades, because all this stuff is pretty much common. Like they don't change as you code. It is common practice. So yeah.
All right. No other questions from online.
Thank you. Anyone else? So yeah. Again, now if we search again for the same thing, we will get the results. We have this that we are loading the data. We are having some data here, like this is our track model with the artist and everything. For some reason, it doesn't load the icon here, but it's okay. It happens. Yeah, you have a list here. Everything is fine. You can remove that. Like do some other stuff. So this is from the real API. That's pretty much the app itself doesn't really matter. It's more about the uses of models and data classes. So that's all for the demo. If there are no questions on that, I can proceed with the presentation. Okay. So some pros and cons about the data class plugin. So as we saw, it's easy to use. It has like faster development iteration by manually doing this, or going through and find all the plugins that you need, or find like understand how the build runner works, what commands you should use, and how you can customize this. It has less dependencies because now you can generate your JSON and the data class and the union classes, and also provide some actions on your code. With one dependency, it produces less code. It only produces like code that you need, because with build runner, for example, and packages, if you have looked into the source code that is generated, it's quite complicated sometimes to understand why it's structured like that, because it can produce code that you don't read it. And also, it's human readable which is one of my favorite things, because you can go through the code that the plugin generated for you and understand pretty fast why it's not working. You don't have to go through other files, find the lines, find whatever needed, and understand why the code is structured like that. It tries to generate the code as you would normally do it by hand. Yeah. So some negative things is that it can require like manual reruns. So if something goes wrong with the plugin and it for some reason it generates wrong code, right? So there is a bug on the library. So that means that you would have to go through all your data classes that might have this error and rerun. So again, you have to run this action again, like by hand. Something that build runners is better at. So it will generate. So build runner, if the library has a bug, it will generate the whole code for the whole project in once. Changes to the generated code will be overridden, except for the case of the constructor, as we saw. And yeah, it cannot generate all your code at once. Like, for example, you would like something like find all the files that have this data class annotation and rerun the code again for me, just to be assured that everything is up to date. So this cannot work yet. So what's next for the data class plugin? There are a lot of thoughts, but for now, one of them is to speed this process for generating the code to the whole project, right? So we need to find a way that does this as quickly as possible. Do any potential fixes, and yeah, bug fixes, improvements, whatever is needed. So this is where you and the community and everyone that will use or try the plugin can provide some feedback. Like we have, this is open source, so you can provide issues or feedback, or you can even contribute. Yeah, we need to enhance the configuration for more options on the generated code. As we saw, we can customize the JSON and the data class, but we need to improve for unions and also maybe enums. And the last step is to reach a production-ready level, so it can be safely used without expecting any breaking changes. Whoops. Yeah. So, if there are any questions around that,
So, ask something.
Yeah.
In the beginning, you mentioned something about flavoring and all this stuff. Was this relevant to this plugin as well? Like in a way, are you planning to expand the plugin to even like be able to flavor the whole application?
Yeah. So.
Because flavoring is like a totally different thing.
Yeah, it was more about the build runner that is used for generating things like that, or in generally code generation, like as a whole thing, not just for this. Yeah. So it tries to do whatever is necessary to keep the speed. So that's why build runner is a bit slower, because it's not just data classes, it's a whole ecosystem of generating different code, like different aspects of an application. We can't do pretty much anything. So this is focused on the data class plugin. The data class, sorry. Anything else? Cool. Yeah. So thank you for listening me and Nikos. And also, I want to thank Nikos for helping me with developing this, and also with the documentation issues. Most of the presentation, yeah. Give a clap for Nikos.
So, one last thing. We would really appreciate your feedback on this, on the plugin itself, and the presentation, and the meetups and everything. So yeah, again, thank you very much.
Thank you.
Well done. Well done. Thank you. So I'll take a picture of the QR code. please, by all means, leave your feedback. So that's a generic form, not just for this session, but for future sessions as well. When it comes to the Flutter Greek community, your voice, your opinion, your thoughts matter, and we'd love to hear them all, pretty much. And I think the time has come to thank once again our very dear Lena and Sae for providing this amazing space. So thank you. Once again, Nikos and Vangelis for the amazing presentation, for all the Flutter interesting conversations, thoughts and tools you may be using in the future, and for the audience that's now online, just to feel jealous, it's pizza and beer time. So, thank you very much, everyone. Let's head over that space. Thank you.